I am Anil Kumar. Welcome to my series on trigonometric inequalities. Let me thank many of my subscribers and viewers who have been requesting for these videos, especially Mr. Ritesh Kohli. Now, Mr. Kohli, thanks a lot for posting all these questions. I'll take their solutions one by one. Now, in this video, I'm going to take a very simple approach to solve inequalities related with trigonometric functions. These are 8 trigonometric inequalities which will be solved in this particular video. You can always pause the video, answer these questions, and then look into my suggestions. So basically, we'll work in a domain which is restricted to 0 to 2 pi, and we'll see when is tan x greater than square root x, when is cot square x greater than half, when is half of cot square x is when half is less than cos square x, when sin square x is less than equal to 3 by 4, and some more questions on this side. Now, feel free to write your comments, share your views, and if there are any suggestions or questions to be answered, you can always send me an email on the address given. Now, let's take these examples one by one. Let's begin with tan x greater than equal to square root of 3. Now here, I will actually take the most simple approach, the simplest of all, to solve all these questions. And what we are going to do here is look into the graph of the function to get an idea what the solution should be. Now tan x has a period of pi, 180 degrees. The graph could be sketched kind of like this, right? So I'm making very rough sketches here, but they help us to provide the correct solution. So that is the whole idea. So let me just sketch the tan x function. It will look like something like this, right? So we have drawn two waves. It goes from minus pi by 2 to pi by 2, right? So these are your zeros. So first zero is at 0, the second one will be at pi, and then the third one will be at 2 pi. So let me just sketch one more cycle here. Okay. Now these zeros correspond to the sin x value of 0, right? Tan is sine over cosine. So 0 pi and 2 pi gives you 3 zeros for tan x. The inequality which we are trying to solve is tan x greater than square root 2. So whenever you have inequalities, you should always think about first, what is the value of x when tan x is equal to square root of 3, right? So when you think about this, you will also remember the special triangle which gives you the value of square root 3. Now, it is 30, 60, 90 or pi by 3 angle which gives you tan of square root of 3, right? And that is your special triangle. So you know that tan x is actually equal to square root of 3 for x equals to pi by 3. So what we do here is we want that tan x value to be greater than this. So let us say this represents the value for tan x equal to square root of 3. So our solution lies when the graph is greater than that, right? So that is what we are looking for. So that is to say, that is our solution. Greater than equal to means these points are included, and we are looking into this part of the graph. Is that clear to you, right? So we are looking into this part of the graph. So within this domain, which is from x greater than equal to 0 to 2 pi, we can clearly see the solution is what? Do you get the idea, right? So from here, we know x is equal to, pi by 3. Now, one more thing will help you to solve these questions, and that is to know when is tan positive and when is tan negative. Well, in quadrant 1 and 3, tan is positive, right? So pi by 3, I could draw a line like this, indicating that this angle here is pi by 3. And so this is 1 pi by 3, 2 pi by 3, 3 pi by 3. This is 4 pi by 3 for us, right? So when we are saying that tan x is greater than, that means our solution lies in the interval between pi by 3 and 90 right there, correct? And also this portion which is right there. So the interval is this. Do you see that part? That little bit of interval is the one where our solution lies. So we could write the solution as the value of x will be equal to. Now it is greater than equal to, right? So this point will be included. However, pi by 2 cannot be included since it is not defined at that point, correct? So therefore, this point here, which is pi by 3, right, will be included. So we can write this as from pi by 3 to pi by 2. This is pi by 2, correct? 2 pi by 2. However, pi by 2 is not included. You get an idea. So that becomes the solution. Union means and this portion also, right, which is from 4 pi by 3. Again, you should include 4 pi by 3, but you cannot include, this is pi by 2, 2 pi by 2, 3 pi by 2, right? So this is 3 pi by 2. Does make sense to you? You cannot include this. So that becomes the solution for our trigonometric inequality. Does it make sense to you? So that is how we are going to solve all these questions. So we'll try to sketch a graph. We'll try to relate the value from our special triangles, see the solution, write it down, right? Now I have a list of videos working with trigonometric inequalities. I'll provide you with a link on that, and there you can see other methods to solve trigonometric inequalities. Perfect. Let's move on and take the next question. Now this time we have secant square x less than equal to 4. Now again, let's try to sketch the function. Now we are working, as I said, between 0 to 2 pi. So secant is inverse of, reciprocal of, I should say, of cosine function, right? So that is the cosine function graph which I have drawn. At 0 there will be vertical asymptotes, right? So from here we'll sketch secant x. Okay, so let's first sketch secant x. Okay, let me just draw this. Perfect. Okay, now when we say secant x, then okay, let's complete this side also. It makes sense, right? Because at 0 we have a vertical asymptote. That's the whole idea. So the value of this secant x will be kind of like this, right? So on this side it will be kind of like this. So these dotted lines are not of our interest. They give us secant x, but we really are interested in secant square x, right? So for secant square x, everything is positive, right? 1 remains 1. 1 remains 1. If it is, a smaller value, it will be like flatter. So the graph will be kind of like this. Let's say, let me just approximate it. And here, the minimum value is going to be positive 1 for secant square x, right? So we kind of get our value of the graph like this. Does it make sense to you? So I hope you understand the concept. So we have got secant square x now. Perfect. So secant square x is less than equal to 4. That means we will try to figure out when is it 4, right? So this is the point where it is 4. So we can say secant square x equals to 4 at this line. Let's find that value. Okay. So we say that secant square x is equal to 4. That means secant x is equal to plus minus square root of 4, which is 2, right? So when is secant x plus minus 2, right? So what we are saying here, secant square is always positive. So we want it to be less than this. So we are looking for something below this. Okay, So we could talk about cos x equals to half. Now when is cos x half? So again, get back to your special triangle, right? Half means you have to look into again this side, right? So which is pi by 3. So cos x is half means x equals to pi by 3. How many times in this particular graph? Now we are looking for both plus and minus, right? We are looking for both plus and minus. So that means, okay, now this is not really pi by 3, but So what we are trying to say here is this is pi by 3, then we have 2 pi by 3. This is 3 pi by 3, so this is 4 pi by 3, right? And this is 5 pi by 3. So these are all the critical numbers which we have to look into, right? Now, when is secant square x less than 2? That means secant x is between 2 and minus 2, you can say. Less than 2, right? So secant square x is this and this. So what we are looking into is cos x is between plus minus half. That is what we are looking into. Is it okay? So if you look into the cos function, cos x is less than equal to half. So let's look into the cosine function. So at half is at pi by 3, right? Pi by 3. So let me draw a line here using a different ink. That will make sense, right? So let's say this is 1. So this is my line for cos x being half. So this is cos x equals to minus half, and this is plus half for cos x, right? So that is for cos x. So those are the points of our interest. Those are the points of our interest. Do you get the idea, right? So even these points, right? These are the points of our interest. Correct? We want the value of secant x to be less than something. Right? So less will be, as you can see from the graph, in between these points. Correct? So in between these points is what we are looking for. Got it? Now our domain is only up to this point, right? So only up to this point. So these are the two intervals which give you the solution. Does it make sense to you? Perfect. Okay. So now we get our solution. That is to say that we are looking for something which is in between this and which is in between this. Those are the points marked there. So we can say that the value of x is equal to, now both are included, right? There are no restrictions on this. So it is included between pi by 3 to 2 pi by 3 and also between 4 pi by 3 and 5 pi by 3. Does it make sense? So in these two examples, actually, we have covered the whole variety. We have looked into a trigonometric function, the primary trigonometric ratio. We also looked into the secondary trigonometric ratio, the reciprocal, and also the square of that. So I hope with this, you should be in a position to answer the rest of the questions, right? So let's share the next one. We are now talking about secant x less than square root of 2. So how will you do this? Well, when you get this secant x less than square root of 2, you can also write this as 1 over cos x as less than square root of 2, right? That is what it is. Okay? Now, what you have to look into here is, we'll again sketch the graph, cos x function secant x is reciprocal of cos x. So there are vertical asymptotes, right? The graph will be kind of like this, as we did last time. But this is not squared, so you'll have negative and positive both. Right? You want secant x to be less than half. So what are you looking for? You are looking for something which is cos x is less than equal to 1 over square root 2, right? Or is it the other way? So when you actually cross multiply, first, this is actually not a good step. I should not write this. This is incorrect. This is incorrect. Okay. Let's try to do with this particular function itself. So what we will do in the first phase is find when is cos x equal to square root of 2. That is also a part of our solution, right? 1 over 2, I'm sorry. When is cos x equal to 1 over 2? Now, if you look into, again, your coordinate plane, cos x is 1 over square root 2 for the values when it is pi by 4, right? 3 pi by 4, 5 pi by 4, or 7 pi by 4. Now, cos x is positive in these quadrants, right? Negative here. So, we want a value which is less than this. So, if it is negative, it is always less than. Remember that part. So, all this is included. Negative is always less, correct? So, when we are saying that we are looking for secant x less than square root of 2, that means here, so 1 over square root 2 will be on the cos x, the 45 degrees, right? So those are the points. So let's look into the cos x points of square root 2 first. And also negative square root 2. So we do get these points, right, where it is square root 2. And those points are clearly marked here, where it is square root 2, right? Now, all these negative values are less than square root 2. So definitely we have a result here which is clear when it is within the domain of secant x but less than square root 2. So 1 over square root 2, let me sketch that also in a different ink. This is nice. Now we haven't used this color. So let's say this is our square root. So we're looking for this graph lower than that, right? So this corresponds to that value. You get an idea, right? So these two values which you are looking into, we have to look into this value, right? Those are the critical points which we are looking at. Now from here, what do you conclude? Between the interval 0 to 2 pi, the solution should be what? From 0, it goes up to this point without any problems, right? And then it increases. So the first interval is from 0 to pi by 4. Correct? So in this interval, it is less than square root 2, both included. After that, it goes up. So that is the value of x. So between 0 to this, up to this point. So in our domain, we get our answer from here to here, right? Then it goes up. Then after pi by 2, it is what we see here that from 7 pi by 2 to 2 pi, it is again below square root 2, right? So let me rewrite this. 7 pi by 2 to 2 pi. Is that clear? 2 pi will be included, correct? So that is how you get the domain for x. Is that clear to you? Perfect. So what you could do here is that you could analyze the graph and write down the answer quickly. Using graph, it is much, much simpler. Now, based on this, you can actually solve rest of the questions. Perfect. So I'd like you to pause the video, answer the rest of the questions, and then look into my suggestions. Correct? Cot square x greater than half. I'd like you to pause the video. Let's take a small break here, and after the break, we'll continue. I hope you enjoyed the wilderness of this beautiful region. There's a lot of snow around, but still we see quite a few animals and birds. It is very refreshing. So with the fresh mind, now let us try to solve the remaining questions. We are working on the inequality cot square x greater than 1 over 2. So that is to say, we need to now figure out what is cot x equals to. Cot x should be 1 over square root 2, or tan x should be equal to square root of 2. Now to find this value, we need to use calculator, right? Remember, we are working in the domain from 0 to 2 pi. That means in radians. So let me first set the calculator in radians, right? So that is that option for radians. And we'll find when is tan x equals to square root 2. So we'll do square root tan inverse of square root 2, right? So what do we get? We get 0.955. So we get x value of 0.955, right? That is what we get, right? So what we know here is that we are actually looking for both. So using calculator, I found the value for square root 2, right? So but we can find all others. So let us say approximately, let's just draw our lines. We know this value here is 0.955, right? So the other value will be, we can add pi to it, right? So if I add pi to this, my answer, I get 4.09669, so I'll make it 7. Okay, so those are the two values. To get this point, I can do pi minus 0.955. So let me write pi minus 0.955. We get 2.186. And to get the other value, I will add pi to this. 5.328. Correct? So we got our values. Now we know that the solution is somewhere close to these values. How do we figure out? For that, let us sketch the graph. Okay. So we're looking into cot square x, and that is our function. Now cot is reciprocal of tan, so the graph of cot square x is kind of like this. So we'll first sketch the graph of cot x. So what I'm sketching here is not cot square x, but cot x. So I'm just making dotted graph. Okay. So I'll just squeeze this into my page. Okay. But that gives you some sense of what it will be looking like. Okay. So if I want to make it cot square x, then everything is positive, right? So the portion which was negative will now be kind of like this, right? So see, this portion will be kind of like this. When we say that we're looking for a value greater than half, so let's say this is a line which says half. So everything above this is our solution. So we get a solution from here to here, right? So that is what all are not, these boundaries are not included. So here to this place, right? And then up to this place, and then from here to this place, right? So these are the intervals which are included for us. Does it make sense to you? So within 0 to 2 pi, those are our solutions. We already know what these points are, correct? Since we know these points, the first one here being 0.955, then we have 2 point, this one, which is 2.18, 6. Then here we have 4.097, and then we have 5.328, and that is 2 pi. So now you can write down the value for x, which is our solution, right? So these points should not be included. One, the inequality is greater than. Second, there are points of discontinuity. Correct? So from here, we can write that the interval is from 0 to 0.955. There's no need to write radians. Radians is the ratio, right? So it doesn't really have a unit. Okay. And then we have from here to there, which is 2.186 to pi. And then we have from pi. You have to have this discontinuity because at pi, cot x is not defined, right? So 4.09 union 5.32 to 2 pi. Is that clear to you? So that is how we are going to get the solution of this particular inequality. Perfect. Let's move on and take the other questions. Now we have sine of x plus pi by 3 equal to half. Now when is sine theta half? Let's say this angle here is theta for us. So sine theta is half when? Well, for this angle it is half, right? Not that. Okay. So that angle it is half, and this angle should be pi by 3. So we know sine theta, let me write phi now, sine phi is equal to half when the angle phi is pi by 3. Now we are interested in finding a solution when it is greater than half. Now sine, all are positive here. Sine is positive in second quadrant, right? So we know one thing, that in our case, it is going to be greater than half between these two values right there, correct? So from the given equation, since we know this is pi by 3, the other one is 2 pi by 3 when it is equal to half, correct? So the solution becomes that x plus pi by 3 should be greater than pi by 3 and should be less than 2 pi by 3. Clear? So what should happen to x? To get the value of x, we have to subtract pi by 3, right? So we have pi by 3 minus pi by 3 and 2 pi by 3 minus pi by 3. So that gives you the solution for x, which should be greater than 0 and less than pi by 3, correct? So that becomes our solution for the given equation. So remember this. So the answer here will be from 0 to pi by 3, correct? So since we are writing in this form all our solution, I have rewritten the solution instead of inequalities in the interval notation. Is that clear to you? The next question here is cos square x is greater than half, right? So, okay, let us quickly sketch and then solve, right? So we have cos x function, which will be kind of like this. We are working in 0 to 2 pi. The square x function will always be positive, never more than 1, right? Something like this, okay? And here again it is going to be like this, okay? Here it will be kind of like this. Not really over it, but as far as the inequalities are concerned, we could consider that to be okay, right? So what you need to work out is when is cos x equals to 1 over square root of 2? That is what we need to find. And that is when x is equal to pi by 4, correct? Now getting back to our quadrants, we know cos is positive, all are positive here, sine, tan and cos. Now the cos is positive in which intervals? In first and fourth quadrant, right? So what we have here is pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4, right? These are the values at which cos square x is equal to 1 over 2, cos square x. So both negative and positive will be taken. We want these values greater than, right? So let's say we sketch it like this. We know these values. We know these values, correct? Perfect. So greater than means from here you can see our answer for x is we are not equal to, right? So we'll not include 0. I mean, this should be 0. Okay, this is pi. So from 0 to the first value where it hits, the graph is pi by 4. Then it goes down, and then again it is up when it is 3 pi by 4. Up to 5 pi by 4. And then again starts here at 7 pi by 4. Till 2 pi. Okay? It is greater than half. So basically, if you look at it, we have a solution here that the cos square x is greater than half when it is closer to this portion. Is it okay? Does it make sense? So that is how you could visualize and get your answer. So I hope this concept of using the graph and the coordinates where one is positive or negative and just finding one value when it is equal to the given thing helps to solve trigonometric inequalities. Perfect. Now the last question here, almost the last question, one more to go. I will leave this for you, right? So we did cos square x. Now you can do sine square x, write down your answer, follow a similar method, and also the last question, which is cot x greater than minus 1. So I'll leave that for you to do. Try to solve these questions, and I hope you find it interesting and useful. Now, we have actually practically solved all these questions. In case you have any doubts, you can always email me. You can also provide me with your answers. So I hope that works. Feel free to make suggestions, write your comments, and share your questions. Let me again thank Mr. Kapil for sharing this particular question. All the best.